Hey, Maslow Maker Made fans, Phil here in Chicago. I wanted to give you an idea that I had and share with you and see what you think. First, let me show you my setup here. I made my frame out of aluminum, tubular aluminum. It's nice and lightweight. It's nice and rigid, nice and flat. That's one thing I like about it. What I did was I created little hangers for it. It hangs on some 3/4 inch pipe. And then this way, when I'm not using it, I can just raise it up to the joist and lock it in place. I think that works out really nice. Another modification I made, I used a pulley instead of the gear, and I find that it works much smoother and much easier. And one other thing I used lead pucks, which you can get plumbing supply or even Home Depot, instead of the bricks. And I find they weigh quite a bit, but they're very low profile and hold up nicely and seem to be working out really well. So one reason I came up with this idea is that I'm using the Maslow to cut out some logos, and then when I go to place the logos, I need a template, and I was having my local print shop make up that template for me, and I said, why can't I turn my Maslow into a printer? And that's actually more of a plotter, but so that's what I decided to do. So let me show you how that works. So we all know that the router mounts inside of this frame. Well, if I take the router out, you have this empty chamber here that is still controlled by the Z-axis and still has a decent amount of weight on it. So what if I replace the router with a magic marker system? How would I do that on such a big hole? Let me show you that next. So the first thing I did was I took some 3-inch PVC, because 3-inch PVC just about fits inside the hole. There was a little bit of slop in there, so what I did was I wrapped it with about 3 layers of some extra wide duct tape, and then for the very last coat, I don't know if you can see it here or not, I did some package sealing, clear package sealing tape on the outside. And what that does is it makes it nice and slippery so that it can slide up and down inside the Z-axis. I cut a little square in there, and that square is I think it's roughly 3/8 by 1/2 inch. Lines up exactly on the same spot. Sorry, as I try to do two things at once here. Lines up and clicks in. So now this whole 3-inch PVC is controllable by the Z-axis. So how do we get a marker into that 3-inch PVC? Well, what I did was I took this innermost one here is a 1/2-inch PVC coupling. Turns out that fits into a 3/4 inch coupling, which fits into a 1-inch coupling, which fits into an 1.25 inch coupling, and that fits into a piece of 2-inch PVC. And so there's a little bit of sanding, maybe on a couple of them that need to be modified, but they fit pretty nicely. I glued them all together, cut them on a nice chop saw, so there's a nice flat surface there. And on this side, you want to make sure you leave yourself a little bit of a lip, and I'll explain why right now. So the way that I designed this is what I have here. This is a access plug that's designed to fit inside the end of a 3-inch piece of PVC, and it stays flush with it. And it just so happens that this inside diameter here is the same diameter as the outside diameter of the 2-inch PVC. So I don't even need glue. It's a really nice snug fit. It stays in there nicely. So now this plug, which fits into here, has a hole in there that will hold a Sharpie marker. Now for this demonstration, I'm using this big Sharpie marker that's about a 3/4 inch hole on it and fit it in there. I have a couple other markers here. This is a little bit smaller Sharpie marker, and this is like a paint pen that fit into there. Even a skinny typical Sharpie marker can go in there as well. However, I'm going to have to leave this unglued and create different inserts that'll fit into there for the various size markers that you plan on using. All right, so I put this cap now on the end of my 3-inch PVC, and another nice little bonus thing is that because this is threaded, you can twist this in or out and adjust the depth of your marker that you put in there just on the 3-inch piece itself. Okay, so what I'm going to do is I'm going to jam this in there. I kind of predetermined the depth on here, and that leaves my marker just a little bit out. I'm going to install that here on the base, and I'm ready to do some printing. Next is the computer end of it. All right, so I have this little gear shape I'm going to make for you today. And what I decided to do was I kept the tool diameter at 1/8 of an inch because that's about the tip of the marker. Target depth, I only went about 1/16 of an inch. Safety height, I'm keeping that small so that the z-axis can raise and lower itself very quickly to get it off the paper. I don't want the marker touching the paper longer than it needs to. Step down, again, I kept that at about 1/16 of an inch, and I also increased the feed rate for the same reason. I don't want the marker moving too slowly on the paper and bleeding in, so I want it to move fairly quickly on the paper. So one of the things you guys want to do is you want to make sure that you reset your z-axis to the marker tip, because you don't want to have to push this too hard nor have it be too shallow. Alright guys, I had to stop the first test run. I'll show you why. The marker, this paper, has some deep creases in it and it's not really tight to the board. So there's a couple spots when it was dragging or it was leaving a line, and then as it started doing the print, I didn't have it set low enough, so it started printing in some areas and not in others. So what I did was I set my depth instead at 1/8 of an inch, and let's see if it works better this time. The flatter the paper, the better is going to be. The flatter your backing, the better off you're going to be as well. Also, and just one note too is that the marker I put in here is a chisel tip, and so because it's a chisel tip, when it's going up it might be wide, when it's going sideways it might be thin, or vice versa. So with a Sharpie marker that has a pointed tip, a conical tip, you'll get a more consistent output. But let's just try it out and see how this goes. All right, well, as you can see, this was the gear image that it was supposed to be making, and this was the result. So not a perfect copy by any means, but even in its current state, if I was just trying to do a drilling template or something, at least I'd have some points that I could use it as a template. There's some kinks that still need to get worked out. I think what happened here, primarily, a lot of it has to do with the smoothness of the paper, and also the marker that was used, getting the depth just right. And one of these paint markers, what's nice about these, and I would have used this except that I don't have the diameter, is that it has a spring-loaded tip in there. And so this way when it's plunging, the tip, would self-adjust as it's doing its tracing, and that wasn't possible with just a static marker. Or I might be able to make an insert for that little cradle that has a spring in it so that the whole marker becomes spring-loaded, and it has a little bit more control that way, or consistent pressure. But on the whole, I think it's a great idea. Hopefully the Maslow community will improve on it, and I'd like to see some of your own posts sometime. Hope this helped, guys. Have a good week.